In the last video, we spoke about the process of deploying a contract to an Ethereum network. I want to mention something that seems kind of interesting at this point in the course. If you recall, when we spoke about sending money from one person to another, we had to create a transaction. And when we sent money from one person to another, that modified the data that was stored on the blockchain. Like, think about it. There's probably on the blockchain some record that says my account has 100 ether and your account has 0 or whatever it might be. And when we submit that transaction, it then updated my balance to maybe 99 and your balance up to 1. In the last video, when we spoke about creating a transaction, creating a contract, we had said that to create that contract and to deploy it to the network, we had to submit a transaction. And so in theory, that's probably updating some data in the blockchain as well. That deployed contract now has to be stored in the blockchain, and we need some record in there that says, hey, here's what the current value of message is. So the common running theme here appears to be that anytime that we want to update any data on the blockchain, we have to submit a transaction. And this is a rule that's going to hold true for absolutely everything we do with Ethereum. Anytime we want to change any data that gets stored on the blockchain, we are going to have to submit a transaction. And what's more, not only do we have to submit the transaction, but we also have to wait for it to be mined or to go through that proof of work algorithm. And that can take anywhere from 10 to 30 seconds to execute. So anytime we are changing any data, we have to submit a transaction and we have to wait for the transaction to be approved before we can say confidently, hey, the data stored on the blockchain has been updated. Now, why is this important? What am I getting at? Well, I want to remind you of something kind of interesting. Remember these two functions down here? We've got our message function and the set message function. So message retrieves a value and set message updates a value. Message is a piece of data that is being stored on the blockchain. It's stored within our contract. And so if we are saying that updating any value on the blockchain involves a transaction, well, what does that mean about set message right here? When we try to run set message, does that involve a transaction? Essentially, if we think about it, set message is changing the blockchain, so it must involve a transaction. But what's even more interesting is get message doesn't change anything at all. So these are two functions. What is the difference between the two if this one has to involve a transaction and this one doesn't? Well, this is a very long introduction from me to introduce a concept of the different ways in which we run functions on our contracts. I'm sorry about the 3-minute introduction there, but I really want to build up the suspense. So here's the deal. There are two ways in which we invoke functions that belong to our contracts. These two ways will result in very different behavior. So we are literally talking about the different ways in which we can execute the function set message or the function to retrieve the message value right here. The first way in which we can call a function is called literally calling a function. When we call a function, it cannot modify the contract's data at all. A good example of this would be our message function down here. This does not modify our contract's data. And in fact, if you hover over this button, right underneath your cursor, you'll see a little pop-up and it says message-call, because that means we are literally calling this function. So I can click it, that results in a call, and we instantly get back some return value that appears right here. Calling a function can return data, as we just saw 1 second ago. So right here, look, here's our return value. It says hi there. When we call a function, it runs instantly because it doesn't involve a transaction. It doesn't need to be mined. And finally, calling a function is free to do. So every single time that we call message right here, instantaneous, free, pretty much behaves the way that you would expect any programming language function call to behave. Calling a function really is the way that you expect it to behave. Where things get really interesting is when we start to want to modify the data that is stored in our contract. So when we want to modify any data that is stored in our contract, we are not going to be calling the function anymore. Now, throughout this course, I might say to you like, oh yeah, we're going to call this function. If I say that, usually it's out of habit. Usually, honestly, making the difference between these two ways of invoking a function, labeling this as calling a function wasn't the best pick, because we say that invoking a function is referred to as calling in just about every other programming language there is. So I might make some verbal typos as we go throughout the course, but essentially anytime that we want to invoke a function that is intended to change some data, we are going to be invoking it by sending a transaction to our contract instance that targets a specific function. When we do this, we can modify a contract's data. And in fact, if you look down at set message right here, that has the purpose of modifying our contract data, it's modifying message right here. If you hover over the button, you'll notice it says set message - transact. Transact meaning we're going to create a transaction that targets this function. Now there's some very important gotchas here, and these are some of the gotchas that I mentioned about Solidity earlier on. There are other gotchas, but these are some of the very biggest ones that we need to be aware of. First, anytime that we submit a transaction to the network, it takes time to be processed. Remember, anytime that like when we sent money from one account to another using the Ringby faucet over here earlier, this took about 30 seconds to be executed. And we now know that it took about 15 seconds for the proof of work algorithm, and then maybe another 10 seconds or something for that to be confirmed by other nodes, and then maybe some other seconds to return an answer back to our site here. So anytime we are trying to update a value, anytime on any contract, it's going to take somewhere from 15 to 30 seconds to actually execute and give us a notification back that says, hey, everything looks good. Secondly, whenever we send a transaction to a function, that returns the transaction hash. So you'll recall that right here, we see right here, here's your transaction ID. This was a transaction hash. So whenever we send a transaction to a function, we get a response back of, hey, here's something that identifies the transaction that occurs, or that you just submitted, excuse me. We do not get a return value back, even if the function that we write has something inside of it that says that we're trying to return a value. So for example, if I change the set message function right here, if I change set message and say after updating message, I want to return message, and then I also update the function signature to say returns string, notice how Solidity, the whole IDE here, Remix, is not really complaining about what I just did. It's not saying, hey, you're trying to return a value here, but this is a function that you're going to invoke with a transaction. So this is very surprising behavior. This is the behavior of Solidity. It is behaving in a way that you probably would not expect. So even though it appears that we can invoke this function and get a value back, that is not the case, because since we want to update some data in the contract, we have to send a transaction, and that is not instantaneous. We don't get a value back, we get back the transaction hash. All right, now I'm going to delete that stuff. I know this is a long video, but this is some very important gotchas that I know are going to come up later. These are gotchas that I just guarantee you are going to come up. So there are things we have to talk about. So last one I want to discuss here is the fact that sending a transaction to a function costs money. This is something that we'll talk about much more in a video or two, and this is something that we've kind of held out discussing at this point in the course so far. But sending a transaction to a function does cost money, and I can prove that to you through the Remix tool. So if we go back over to the Run tab here, so here's Run, I'm going to make sure I still have my JavaScript VM selected, and I'm going to select an account that appears to still have 100 ethers inside of it. So make sure you select an account that has 100 ether. Then I'm going to go down to the bottom where I've got my deployed contract right here, and I'm going to send a message, or excuse me, I'm going to invoke set message and attempt to update a value stored in the blockchain. So I'll say, greetings, and then I'll run it. It gets processed, but if you look back up at the account balance, you'll notice that it's now gone down to 99.99999 blah, blah, blah ether. So it cost very little ether, but it did cost money to update the value here. Now there might be something that you are very confused about right now when I called set message just a second ago. That touches back on the fact that I just mentioned that it takes time to execute. So I'm saying right now, hey, it takes time to execute anything that updates data. However, it appears that in Remix, whenever we call set message, like, let's do something else here, whenever I click that, it sure appears to me to be instantaneous, right? Like, that looks awfully instantaneous. The difference here is that it takes time to execute these transactions when we are on public networks. So on the main Ethereum network, on Ropsten, on Kovan, on Rinkeby, on all these public test networks, there is a block time of 15 seconds. However, on any test network, like the one that you and I are using right now, this simulated local network running inside the browser, the transaction block time, or excuse me, just the block time, gets tuned way down to be near instantaneous. So this is a huge gotcha, the biggest gotcha. Like, I got my hands on my head in real life right now. I gotta tell you, I just totaled such a gotcha, like a mind-blowing, interesting thing. Because anytime you go and look at a tutorial around Solidity and Ethereum contracts and all this stuff, it's always written using these networks that instantly process transactions. And so you will see a tremendous amount of content out there around building Ethereum apps that are all set up assuming that these transactions get approved instantaneously, because they are running these network or these transactions on local test networks that process transactions instantly. However, in the real world, as our users actually interact with these apps that you and I are going to build, anytime we try to update some data, we have to wait that 15 to 30 seconds for that data to be processed. And this is completely shocking. I want you to think about it for a second. Imagine that you are building, let's say, Twitter. Like, let's go look at Twitter right now. So when we are running, let's imagine that we were building Twitter on top of the Ethereum blockchain. If we were developing our application and while developing it, we were using a local network, and let's say I entered in like a new tweet right here and then clicked on tweet. On a local test network, usually they are configured to instantly process these transactions, exactly as you see right down here with a set message button. When I click this, it instantly processes the transaction. But in the real world, like if we were actually working with Twitter with a real Ethereum network, like the main network, when I clicked on tweet right here, it would take 15 to 20 seconds for that to actually be processed. And so whenever we build these Ethereum apps, we have to keep that in mind. We have to make sure that when a user clicks a button, we show something that says, hey, you just submitted a transaction. This is going to take 15 seconds to process. Please hold on while that runs. And I find that this is actually a really big shock to people who are first getting involved in Ethereum, because usually you and I are used to changing data, like making a tweet, clicking tweet, and then instantaneously, poof, there it is. It got written to some database. But with the way that Ethereum works, we have to wait for that block time to actually see the transaction confirmed and reflect the new value in the blockchain. Whew. All right, so that's my rant about transaction times. The point here is that when we are running these test networks locally, we get unrealistic times to complete transactions. We do that because, hey, it makes it easier for you and I to develop things. But the flip side is that usually you just need to be aware that your development environment is very different from the real environment. And that's why, by the way, I've said so constantly that we're going to be using the Rinkeby test network so that when you and I start building actual applications, we see that big delay. I personally want to see that 10-second delay or 15 seconds, whatever it is, that it takes to write data to the network, so that I make sure that I build my application in such a way that users are informed that, hey, this writing action takes 15 seconds or whatever it might be. Okay, for real, I'm done. Let's pause right here. This was probably a lot more than you wanted to hear. So let's continue in the next video. We'll do a quick recap on running these contract functions, and then we'll talk about what all this cost money to invoke functions means. So I'll see you in just a minute.